Season 5 of Stranger Things, they got a lot of physics stuff going on in there. One of the things that they talk about are wormholes, and in the show there's a wormhole that connects Hawkins to the abyss. Wormholes are also called Einstein-Rosen bridges because Albert Einstein and Rosen, another physicist, worked on a paper where they described a region of space-time that was so intensely curved that it actually connected to another part of space-time. And it was a kind of bridge. You have flat space-time funnels into very, very curved space-time, tightest point of the bridge, and then it expands out again and becomes flat again on the other side. That's the idea of the Einstein-Rosen bridge, or a wormhole. Comes from Einstein's general theory of relativity, which describes the curvature of space-time and the behavior of matter and energy in that curved space-time. So, what does the show get right? What does the show get wrong? It is not physically possible to travel through a wormhole if they exist at all. We're not sure that they exist. Let's say a human being was trying to travel through a wormhole or in a ship, a rocket ship or something. You would need to get to a point of really, really intense curvature, which means really, really intense tidal forces. So it would likely be blown apart on its way through this wormhole. So wormholes are not, as far as we know, real. They're a solution to Einstein's field equations. Now, even if you could get through a wormhole, what would you see on the other side? It would be another normal region of space-time, right? As long as you made it through and you were on the other side, you would just be in a different part of the universe, importantly at a different time, also relative to where you started out at. But there's no reason to think there's going to be scary monsters and red lightning on the other side of the wormhole. Now, one way to think about wormholes is to use something called a Penrose diagram. It was created by Roger Penrose and a collaborator of his. You have 4 different quadrants of your Penrose diagram. You've got quadrant 1 and 2. Quadrant 1 is kind of like space-like, so you can move through that region of space-time, and the boundary that separates quadrant 1 from quadrant 2 could be thought of as like the event horizon of this structure. Say it's a wormhole. That's the event horizon of the wormhole, the point of no return, the point where when you cross that line, you have to go through. And so that second region is usually called a time-like region, right? A good way to think about them or maybe analyze them theoretically is through a Penrose diagram, because quadrants 3 and 4 might be considered the other side of a wormhole. At least according to Leonard Susskind, there's no reason to think that regions 3 and 4 are actually real. We don't really consider them, but they do look cool in a Penrose diagram, and it is a solution to the equations. It works, the math works, but of course that doesn't mean that it's real. It doesn't seem like they exist, maybe they do, but there's probably not spooky monsters on the other side.